So we're going to talk about the Pythagorean identity first, which is just x squared plus y squared is equal to the hypotenuse squared. You can use any letter you want. That is for any right triangle where you have x, y, and the hypotenuse z. But when we talk about the Pythagorean identities here, with the unit circle, our radius is 1. So what that means is it's not z anymore, it's 1 squared or just 1. Now, what I'm going to do with this is, because I know on the unit circle x has the same value as the cosine of theta, and y has the same value as the sine of theta, I'm going to go ahead and replace those. So wherever I have x, I put the cosine, and wherever I have y, I put the sine. So that gives us the cosine squared of theta plus the sine squared of theta is equal to 1. And that's our main and our first Pythagorean identity. However, I can also go through and relate those with the tangent and the cotangent. The way I can do that is just with a little bit of algebra. So if I take my first one, I take the cosine of squared of theta plus the sine squared of theta is equal to 1. If I divide everything by the cosine squared of theta, what do I get? Well, cosine over cosine, that is just equal to 1. For the next piece here, the sine squared over the cosine squared, that is the same thing as saying the tangent squared of theta. And the last one, 1 over the cosine, is equal to the secant squared of theta. Now, one note that's really important here, when I say any of the trig functions, tangent squared of theta, what that means is the quantity of tangent theta squared, not the angle itself squared. Now, I can do the same thing again and get the next identity, only the next time I would divide through by the sine squared. And if I did that, the last identity would become 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. Now we're going to go ahead and use these in the next part of this video. Now these identities are useful because if I ever, and you might see this on your homework somewhere, if I ever say what is the sine of pi over 5 plus squared plus the cosine of pi over 5 squared, you know that equals 1. Alright, so to use the Pythagorean identities, if I'm giving you that the sine of theta is equal to 3 over 5, and that theta is between 0 and pi over 2. Now I need this phrase here because what this means is that puts the angle in the first quadrant, because whether the value of the sine, cosine, tangent is positive or negative is based upon the quadrant. So putting it in the first quadrant tells us that it will always be positive. So going through and looking at the identity that I need, the identity here is that I have the sine squared of theta plus the cosine squared of theta is equal to 1. And remember what I said in the last slide, this means this is sine of theta, quantity squared, plus cosine of theta, quantity squared is equal to 1. So all I'm doing with this is I take that 3 over 5 and I plug it on in down here. And now I'm left with 3/5 squared plus cosine of theta squared is equal to 1. Now, this takes a little bit of math, but not much. I go through and I square my fraction. When you square a fraction, it's just numerator squared and denominator, so that becomes 9 over 25 plus the cosine of theta squared is equal to 1. Now I have to subtract 9 over 25 from both sides. I need to find a common denominator here. So to do this, this becomes 1 minus 9 over 25. I rewrite 1, and instead of writing it as 1, I write it as 25 over 25. And 9 minus 25 gives me 16 over 25. So after subtracting that from both sides, I get the cosine of theta squared is equal to 16 over 25. I now take the square root of both sides, and this is the reason why I needed to know whether it's positive or negative, because in the very beginning we said that theta had to be between pi over 2 and 0, which is the first quadrant. I know that answer has to be positive, so that's going to be a positive 4 over 5. Now, let's do one more. Let's go ahead and say what would happen if I have the sine of theta is equal to 6, and I want to find cosine of theta, but I want theta to be between 0 and pi over 2, which again puts that in quadrant 1, which makes all of those values of cosine positive. All right, so I start with my sine squared of theta plus cosine squared of theta is equal to 1. So my sine squared becomes 7/8 squared plus cosine squared of theta is equal to 1. 7/8 squared is 49 over 64 plus cosine squared of theta is equal to 1. You want to now go ahead and subtract 49 over 64 from both sides. So that gives us 1 minus 49 over 64. Turn that 1 into 64 over 64 minus 49 over 64, which just equals 15 over 64. So now I know that the cosine squared of theta is equal to 15 over 64. And again, I know when I take the square root of this, it has to be positive. There is a possibility it was negative, but because we're in the first quadrant, it must be positive. So now I know that the cosine of theta needs to equal the square root of 15 all over 8.